Hello, Algebra 2 Trig. This is the notes for week 5. We were talking about systems of linear equations. I know we did this in Algebra 1, but I was racking my brain. I don't think we did this in class when we had normal school. So, solving a system of equation. Basically, it looks something like this. We are talking about linear systems of linear equations. So, this first equation is a line. The second equation, it's a line. But because they are related together, and that's kind of what this bracket is doing, this is called a system of equations. You can have two equations, two variables, three equations, three variables, and so on. The more variables you have, the more complicated it gets. We're going to stick to linear equations, so two variables, two equations. So we're going to try to solve these things. Now, basically the answer to this is knowing what are these variables. So our answer is an x value and it's a y value. But basically, that means it's a point. If you think back to geometry class, this is a line, it intersects another line at exactly 1 point. So the answer is a coordinate. It's an x coordinate, it's a y coordinate. And so that is what we're looking for. So we got a couple of different ways to solve it. One is graphing. We can see where these lines intersect. The other way is substitution. We're going to talk about elimination as well. So the idea of substitution, you're going to take one equation, it doesn't matter which, and you're going to take one of the variables, it doesn't matter which. Look for the easiest. And you want to solve that one equation for that one variable. So I'm looking at all of this, and I'm seeing this y. That's going to be the easiest variable to solve for in our whole system. So that's the first step in solving with substitution. Solve one of those equations for one of the variables. So just going to subtract the 7x from both sides. All right, this negative 7x plus 22, this is what y equals. We are going to substitute that into the other equation. So we're going to rewrite that first equation. 6x minus 5 times y, but we substituted y out with what y equaled from the second equation. Equals a negative 28. Okay, so the reason we do this, we went from two equations with two variables to, after the substitution, we went to this. It's one equation with only one variable, x. We can solve for x. So that's what we start to do next. This becomes plus 35x minus 110 equals a negative 28. Combine your like terms, we get 41x equals, add 110 to this. Oh boy, 90, is that going to be 82? That's convenient. All right, divide by 41, x is equal to 2. That's part of our answer. What we're missing is the y value. So, it just so happens we had this equation right up here that says y equals. Use it. So y equals negative 7 times the x value of 2 plus 22. So that's a negative 14 plus 22. That is 8 for the y value. That is our answer, the coordinate of 2, 8. It's an x value, it's a y value. That solves the system. So that's substitution, solving one equation for one variable. Another method is called elimination. And we're going to do this, it has the same goal as the substitution. That goal is right here, getting this one equation with the one variable. Elimination has the same goal, it goes about it in a different way. So, just by the name, elimination, we're going to eliminate something. So what we're looking for is the easiest way to get the same variable, either the x's or the y's, and it doesn't matter which, to get them to be either the same, so getting both of these to be a positive 4x, or getting both of these to be, well, I would go with 45y. And so, whichever one is the easiest way to go. So you can get them to be the same, exactly the same, so positive 4x, positive 4x. What I'm going to do is get it to be the opposite. And I'll talk about that in a minute. So what we're going to do to get these to be the same, we're going to take this whole second equation and we're going to multiply it by a -4. Okay, so this first equation, we didn't change it, I'm just rewriting it. The second equation, you got to multiply everything by -4. So -4x minus 20y equals a -16. I'm putting this line underneath it. So the idea of the elimination method, we want to get rid of one of those variables. We want to eliminate it. So these x's, I've made them to be the same number, 4x, but one's positive, one's negative. So basically what I'm going to do is add these two equations. 4x plus a -4x, that's 0. Those x's are eliminated. -9y plus a -20y, -29y. I'm going to bring down the equal sign. -42 plus a -16 is a -58. Here's our goal. We got one equation, one variable, so we can solve for it. So divide by a -29, oh, convenient. Y is 2. Again, our answer, it's a coordinate, x, comma, y. We got the y value first this time, no big deal. We're missing the x value. So same idea, bring this y value back up to one of your two original equations. Doesn't matter which. I'm going to go with the second one because I'm solving for x and this is the easiest one to do that. So y is 2 equals 4, x plus 10 equals 4. That means x equals a -6. There's our solution to this system. All right, so some other ideas with elimination. I like to get one of the variables to be the same number, same coefficient, 4, but opposite signs. That way I can just add the equations. The other way to go about this, let me see if I can change colors here. The other ways you can go about this is getting them to be exactly the same. So I would just multiply by a positive 4x. So what that would do is make that a positive, it would make this a positive 20y, it would make this a positive 16. When you get the variables to be the exact same, you're not going to add these two equations, you're going to subtract them. 4x minus 4x is still 0x. We still eliminated that. That's our goal, is to eliminate one of those variables. All right, that's elimination method. So those are the two ways, substitution, elimination. Those are the big two ways. When you get into more complicated 3 variables, 4 variable kinds of systems, there's some other ways to go about it. Hopefully when all this madness clears up, we'll be able to talk about it in some class. Okay, so I want to talk about the setup for this. These are the applications, basically story problems. When you start to think about how to solve these things, the question tells you what you need to do. So you got this Courtney person collects stamps. You got 88 of them. They're worth $15.56. Super. Some are 25-cent stamps. Some are 2-cent stamps. I should have mentioned all this stuff was in your notes. These are just examples pulled from your notes. But the question is, how many of each stamp does she have? Okay, she has 2 kinds of stamps. We don't know how many they are. How many of each they are. So there's our variables. I'm going to call the 25-cent stamps X. I'm going to call the 2-cent stamps Y. Okay, how many of each? So we're trying to solve for both X and Y. How many do we have of each one? It says Courtney has a total of 88 stamps. So I don't know how many 25-cent stamps she has, but I'm going to add them to how many 2-cent stamps she has. That's 88 stamps. There's one of our equations. Now the other piece of information we have is how much they are worth. So if she had 2 of these 25-cent stamps, that's worth 50 cents. Again, wow, super. But either way, we take the value of it, multiply by how many we have, and that gets us another equation. So 0.25 times how many 25-cent stamps we have. We're going to add that to 0.02, 2 cents for each of those stamps that we have. When you add up all this, you get the total value, $15.56. There's our system of equations. Okay. Once you set up the equation from the story problem, You can choose substitution, elimination. It really doesn't matter. It's up to you. But that's the idea of how to set these things up. I hope this helps. I hope everybody's doing well. Take care of yourself and your family.